let's look at the compass, because the compass has that same panel in it. So that gives us a lot of universality. So the compass looks like this when it comes out of the box. Of course, you flip the door off, and this is what it looks like inside. Still very open, very easy to get to the gas valve to adjust it, very easy to get to everything inside. So the sides look like this. Here's a slight view of the back, and here's a full view of the back. So you guys can see here that we've given you these pipes. They're all union adapters with gaskets. We give you spare gaskets to replace after you take them off and put them to the other side, which we'll show you in a second. And all these nuts are available from the front. So you can get on your hands and knees and slide your wrench back in there and tighten these nuts up if this is up against the wall. Now, you'll not be able to change those pipes if it's against the wall. So please change your piping before you slide it up against the wall. Cool. This is the control that's on the front. It's a dial and 4 buttons, which we'll get into depth here in a little bit. And there's the front of it again. So here we are looking at the side, and I just wanted to give you the sizes of those adapters. So the central heating supply is 1.25" male pipe thread. The supply to your indirect water heater or your domestic hot water is 3/4 NPT. Your central heat return, of course, is 1.25", and your gas piping is 3/4 inch. So all these pipes are male pipe thread. So you're going to go on to them with female adapters. Cool. So if you want to change the central heat piping, you would take you'd unscrew the knockouts out on the side you're going to move them to. You undo the nuts, you flip them over, you put the new gaskets in, you change the pipes. Whatever was high on one side is now going to shift over and be the other. So now your supply is going to be return is going to be the supply, and out it goes out the other side, right? It's all marked. It's very easy to do. But remember to save the knockouts because you're going to screw them back in on the holes that you took off. Also for the domestic hot water, it's the same thing. Off it comes. One of the things I wanted to show you while we're looking at this, and I probably should have showed you on the last one, but we allow you, if this is the return here, if you don't want to use the side return, if you want to come in this side with the return, you can and have your supply come out here. Or you can use the cap and cap this off and come out and have your return and supply for the heating here and your hot and cold water here. That's just showing you the central heat domestic hot water pipes again, going out the other sides, being flipped over and brought around.
And guys, take note of the metal flanges that are shown in the photos there. Everything was designed so that the pipes are well supported in the cabinet. So you don't have to worry too much about the guy in your team with the 3-foot pipe wrench, but it is designed so that if you manage to break it, you're probably trying.
We've said that on the TRX and the FTVN.
Well, I got to tell you, I just changed the pipes from one side to the other yesterday when we installed one of these in the van, and those flanges are held pretty tight.
Pretty cool. Pretty cool. So gas, of course, you can take out either side. Pretty easy to do. And of course, piping and wiring. So here shows you a picture with the indirect with all the piping at the left. You could have the indirect anywhere. We put it over here on the right-hand side of the picture because it's out of the way, and we had room over there when we drew it. But this is basically, you're going to have everything off to the left of this thing. You can see we've taken the zone valves and we've run the 24-volt power supply through each and jumped it across for the zone 1 and 2 and fed that down to zone 1 and 2 zone valves. You can see that the system pump is going up to the central heat pump. Of course, we don't need a domestic hot water pump here because it's coming right off the boiler with the boiler circulator, and you have your 120-volt input. So that would be 120-volt input, domestic hot water pump if you needed it. Central heat pump is right here coming down, of course, zone 1 and zone 2. So, and now if you're using circulators, oh, no, we're just going to jump around the other way. I wanted to show this. So this is showing everything coming off the left. But if you're really going to have your indirect off to one side and your zones to the other, wouldn't it just be easier to do this where you have your indirect going off one side and your supply and return going off to your system off the other side. So this is all doable. It's the same wiring. You can do it either way, but you have to make a choice. You can't have the cold water coming on one side to the domestic and the hot water out the other. All your domestic has to go out one side or the other. You're heating either straight through or on one side or on the other. Does that make sense? I hope. So that's that gives you where we're at with that. So here's using circulators. Of course, now we've jumped out the 120 volt input on the line side. We brought it over to supply the zone pumps. So we're getting our 120 volt from there going down to the junction box. Here's just showing it jumped again, going off with that combi using the plate heat exchanger. You can see the 3-way valve there that we suggest that you use whenever you're using a combi. And of course, the domestic hot water makeup and the zone 1 and zone 2. So you see it's pretty damn universal, and we quite enjoy that. So, but now let's look at the programming and the control. What's up, Ted?
Dave, can I make one point? Just because you said universal, and I don't know if the picture ever clearly showed it, but on the manifold that we supply, there's a ball valve. There it is, in between the two T's. And so just in mind with keeping it universal, if you're connecting this in a retrofit situation to a system that already has a hydro separator, for instance, you can shut that valve off, and then the internal circulator simply becomes the injection pump, basically the primary pump, but it's injecting into the hydro separator, and you're not using the closely spaced heats, if you will, in the boiler.
Good point, Ted. Thank you. Cool. So back to programming. So this controls universal with the Series 2s and all the compasses. This control we've looked at for, I don't know, how long did we play with this control? 2 years, 3 years before we came up with this one?
It was a good while.
But we landed on this one because it had the best display and the easiest to use. So first, you got to light this bad puppy up because it goes to sleep. Touch any button, it comes up and says hello and gives you, it reads everything on the screen that you're running. It shows you your outlet temperature. It shows you the power the boiler is running at. It tells you whether your air purge is going on, so you know why it's going on and off. It tells you your flame signal, burner power, outdoor temperature if you have your outdoor sensor or you're hooked up to the Wi-Fi and you've registered on your portal. Tells you what the boiler status is, and of course gives you your date and time if you set it or if you put it onto the Wi-Fi. So that's all on the screen. So press any key to make it happy, press the escape key, everything lights up, and press the menu button. I enjoyed showing this at ASHRAE because when we press the menu button, this is the screen that comes up, and the first line is what everybody has asked for, which is the setup wizard. So the setup wizard, which we had always built into the TFTN, is a phenomenal thing that all you have to do is answer a few questions. So if you wanted to dial into anything else, of course, you would just rotate the dial and it goes up and down through that menu, which we'll get to. But you press the enter button and it takes you to the setup wizard. And now you answer the questions. You just dial it in, hit enter, it saves it. And go to the temperature, hit enter, go to the temperature, your minimum temperature, dial it in, hit enter, your outdoor temperature, use the dial and change it, hit enter, domestic hot water mode, whether it's a tank sensor or an aquastat, dial it in and hit enter. And the domestic hot water set point adjust if it's desired. So if you're using a sensor, this is where you would adjust the temperature off the sensor coming from the indirect water heater. David, here's a question for you. If you're using an aquastat, does this screen come up or not?
just a moment. I'm sorry, I was just answering another question. The answer is yes. I believe it always comes up
Always
regardless.
comes up. So that hasn't changed between the two. So that's still there. So if you used a Aquastat, you don't have to adjust anything here, just hit enter.
Yeah.
So would you like to enable password protection? This is kind of fun because the built-in password is NTI net. And if you want it on, then just hit it on, and then the people can't get into this unless they use the NTI net password. Would you like to connect your product to the internet? Now, we were just talking about this. Dave and I were just having some fun with this earlier. You know, I taught you guys, those of you who've been around, probably what, a year ago, maybe two, how to hook up everything using the manual way to hook up to the internet. All you have to do if you hit yes here is get out. Once you hit yes, it goes to access point. And once you hit access point, all you have to do is bring up the NTI Net app on your phone. It finds the boiler, knows all the information. You put in the people's Wi-Fi gateway, and you put in their password, and you're done. And it's pretty easy. So boiler details. Hit enter. This just gives you the boiler details. Dave, you want to say anything about this screen?
Well, actually, from coming from the tech world where I just left last year, the thing I like about this the best is just you can now see up to, 5 parameters at a time. So instead of going, menu 821, 822, 823, or scrolling through, now you can see inlet and outlet on the same screen, or fan speed, gas power, it's just the ability to see more information all at the same time is, I find, tremendously helpful when I'm troubleshooting. And it's just so much easier to get to.
It's awesome. It really is an awesome control. So hit enter. So we're back to where we were, right? So press the menu button. Use the dial to highlight the section to test. Hit enter, go to test mode. Now we're going to do a combustion analysis. Watch how easy this is. Burner test, minimum power and maximum power buttons. How easy is that? You just hit, and you highlight what you want, hit enter, you go to the next, hit enter, and you're done. Oh, look who shut up. Hi, Jason.
Hey guys, good evening. Hey, there's that control. I love that control.
So if you go to max power, it goes to 100%. And I don't know why it's highlighted as minimum power going to 100, but that's okay. So boiler maintenance. Wow. So boiler maintenance is pretty easy, I guess, right, Dave?
It is really that. It really is easy. It's too easy not to do it.
No excuses, in other words.
No,
Yeah, exactly.
Exactly.
It's too easy not to do it.
Oh, I need to go back one thing here. So a question came in. I don't know if one of you guys answered it. Will it be able to use the new controller with an old FTVN? And the answer is no.
When the new control is backwards compatible, in terms of if you took a control out of a boiler today and retrofitted it, it would work in the older boiler.
The motherboard. That's the motherboard.
Yes. Now the screen will not retrofit, not without significant effort, such as a whole new cabinet and wiring and all sorts of other stuff that you don't want to do. Ask me how I know.
Wait 1 second. Actually, you can, but it doesn't need all that much wiring. What it really needs is to replace the board and a new door. That's about it. There's one wire that comes in a conversion. But am I missing something? It seems like I put this control on an old FTBN with just doing those few things.
No, I mean the controller will fit. I think where I'm coming from is more if you want to get the full advantage, because the bit that and I was typing, so maybe I missed it, but when it comes to the 2 zone outputs with the 2 circulators and all that stuff that you can do now that you couldn't before, That requires all new harnesses. And then the mounting for the electrical panel requires some significant cabinet modification. So I guess just the screen can retrofit. You won't get the other benefits that come with the new boiler. If you just
Yeah,
change the screen, you will
you're
get the
gonna,
new, which is
you'll
probably,
you get access to a number of these, but you won't, right, correct, you won't get all. For instance, you can't obviously control the two different circulators and so forth. But um, if you're, maybe I digress on unnecessarily, but it seemed like there was sort of a halfway path to retrofitting.
Well, I know how you can solve all this. Buy another boiler.
yeah, get a new boiler, yeah.
You like that one?
Makes perfect sense. But yes, it is retrofittable. It is not an easy retrofit. And yes, you can use this dial on the old boilers, but it doesn't talk to the motherboard. So you need to replace the motherboard.
That's true.
So it's the motherboard that's on the Series 2 is downward compatible, but the Series 1 cannot go up to a Series 2 because the Series 2 board is made to talk to this screen. Does that make sense?
It does.
And it will also talk to the touch button. Anyway, cool. So boiler maintenance, which I love. Why is it required? I love these slides, David. What is required? When is it required? And when does the maintenance, when do the maintenance, or when should you do the maintenance is what it should say, right? So we try to blend it all into one, and it's pretty funny. But why is it required? During the normal operation, of course, in a condensing boiler will build up corrosion and combustion debris inside, right? And when we start to build that up, of course, we increase the flue temperature, we decrease the efficiency dramatically, we decrease the heat output, we decrease the reliability, we increase the service call outs, or what we call after hour timing. So these are things you have to look. And if you look here, God, if I could just get my cursor over here, it is. If you look here, what we find is that these tubes get blocked up in the first half to inch that need to be cleaned out. It's not the entire tube that normally gets dirty. It's just the top of the tubes that need to be cleaned out and brushed out. So can you clog the entire tube? I guess you can. It's best if you have a condensing boiler, have it in condensing mode so the bottom is being washed out. But this is what you're going to find when you open it up. So, and take note of what it is. I have opened these boilers up that look perfectly clean, like the day they were born, except for a little bit of heat marks. I've also opened them up where you can't see the tubing at all. So what is required? The burner door for the burner needs to be removed, right? So obviously, if you have to clean the combustion chamber, you have to take the blower and the burner door off. While the burner door is off, and the chamber should be inspected for debris, for scorching, changes in color. David has provided to all of us a stainless steel color chart, so we know how much you took it to, right? So foreign matter that's come in, and any leakage. Of course, the leakage would be caused by probably magnetite buildup and cracking the tube sheet, but I digress. What's required continued, right? So you remove the burner door, you inspect the gasket and chamber. Most of the gaskets may be used for several cleanings on these, unlike the original TFTNs where you had to have the insulation. On these, you can reuse it. And I'll get to that. I'll answer that in a second. Vacuum the loose debris, of course. Use a soot vacuum, use a stiff plastic brush and plenty of water to flush all the debris down the drain. I will say that if you can get this, our brush kit into there, God bless you, because I've never been able to do it. It requires you a right angle adapter on a drill, and you can get it in there, but it isn't really easy. So have you done it, Dave?
To be honest, anytime the last few fire tubes I've cleaned, if I needed to brush them, I just held it by hand and just gave it a little swish around, and that's about all that was required. And then usually just poured a few bottles of water down, and they were so not dirty that it hasn't been a real concern. But yeah, no, I've never done it with a drill, just by hand.
Okay, because I've tried it with a drill, and I've tried it with my right angle adapter, and it was not comfortable.
No, I imagine it was. No, the last couple I cleaned were I opened it up, I looked inside, and I thought, it's probably could be done every second or third year, but.
Yep.
So.
Yep. So rinse it with white vinegar and let it stand for 10 minutes to pickle this stainless steel. And if you guys don't know what pickling is, from the brewing industry, every time we get a new fermenter, whenever you work on stainless, you scrub off some of the chromium and some of the nickel off the surface. And what pickling does, by putting an acid solution on the stainless, it actually brings the chromium nickel back to the surface, so it creates the stainless barrier between what is inside and this actual steel that's built into the boiler. So
I will throw this out there, Steve. I had a couple of people say they don't like vinegar because it smells bad. You can use citric acid as well. To be honest, you could probably use Diet Coke in there. I mean, Diet Coke will take rust off the chrome bumper.
That'd probably be the safest.
But citric acid, if you go to like a baking supply store, you can get that and mix it with water. I'll have to look and see what concentration, but I don't think you could really go too far wrong with any citric acid solution. So it'll smell a bit better, and but it requires a bit more work.
well, and we can get into the brewing world where we use things like Burkox and Star San, and Burkox you have to wear gloves up to your shoulders with, but Star San you can literally pour it on your hands and it's pH at 2.5, it'll work just fine. So and edible and has no smell, but it's, you got to go travel for it and you got to find it, and it's a pain in the ass. Where vinegar, you can go to Costco and get a case of it for $2 for a 2.5 gallon container. So I mean,
Yeah, but some people don't like the smell of it. He's right. They complain.
there's
It leaves
so
an
many,
odor.
so many
It
things.
leaves an odor.
So after you let it stand with the vinegar on it, rinse it off with water. And if needed, wash the burner, but not normally required. Now, Dave had given me, and I think the next screen, let me see, there's a burner. Dave had given me a good analogy of burners. So you all have shop vacs, right? So, and you use a shop vac in your basement and you suck all that shit up, but eventually the filter inside gets clogged. And as time goes on, it has less and less and less and less suction power, and you have to replace the filter. So in our burner, what you have to do is rinse it off from the outside in, from the inside out, and from the outside in again, and then rinse it about, and then reinstall it. So it's kind of like do the hokey pokey with your burner, right? So this is what's important. Rinse it out with plenty of water. If needed, wash the burner. Not normally use the water and flush both directions. As I said, clean the condensate trap, and this is something that's often mixed. And a lot of times what I will do is before I start cleaning these is actually disassemble the condensate trap and put a bucket underneath there to put anything in that you're using to clean it, and just let it sit in there, because any vinegar that you're using or acidic solution will actually help clean the ball off and all the other stuff that was inside. And then perform a combustion test. Now, I was on a job today that was making a lot of whining sound at the low end, which means that the offset was not set correctly on the gas valve. And if you weren't here for Dave's presentation on negative pressure gas valves, you should have been here, because it explained how to set it and what you're doing when you set it. But when you do a combustion analysis, you must do it at high and low, and you must know what screw does what, right? So it's, please read the directions on that and please follow them completely. So anyway, this is the one screen I wanted to show you just for safety. I know we tell you that you can reuse the gaskets. It's all fine and good. But if you have the gasket cleaning kit with you, if you need anything, you have it. Now, if you don't use it, that's fine. You might be able to charge for this thing 4 or 5 times if you don't use it. But if you need an igniter, if you need a flame sensor, if you need a burner gasket, if you need a door gasket, if you need anything, it's all in here. And then you just buy that one part after you use that part on the boiler after you cleaned it or while cleaning it. So please make sure you do that. Cool. So when is maintenance required? It's recommended that you check combustion chamber on every job after 1 year. This is something that Kevin Dennison, I think, burnt into David and mine's and Ted and Jason's heads up in St. John, that he, for years we said, I never have to touch a fire tube. It's okay. Just let it go. And now with especially with the new gasket where you can take the burner door off multiple times, we do recommend that you open up the burner after the first year, because this is going to tell you how often you're going to have to maintain it, right? So if you open it up and you find this, right? So you have to clean it annually. You're going to have to go in there and clean it annually. If the boiler's not dirty, every second year might be acceptable. And really the rule of thumb in our end of the world is if your supply temperature, if your stack temperature is running close to 30 degrees over your supply temperature, you need to clean it. And depending on your outdoor temperature, we have found, somebody asked me this the other day, and in field, and David, you can add into this, in me working in the field, depending on the outdoor temperature, I have seen the flue temperature be anywhere between 10 degrees below the supply temperature to about 12 degrees over the supply temperature on a normal situation with hot air outside. What have you found, David?
No, that's generally what they should be. Is if it's running at a nice steady state, and preferably not 100% fire. So you might see it temporarily go a few degrees above or below, but generally speaking, your flue gas temperature is going to be at most 10, maybe 15 degrees hotter than your supply. And in some cases, it'll actually be less than the, as Steve was saying, it'll be less than the supply temp, usually 10 to 20 degrees hotter than the return. So 10 to 20 over the return temp, you're fine. Once you start hitting 10 to 20 above the supply temperature, you're starting to run into a situation where you're not transferring heat perhaps as well as you could be. And I would add, even if you're not cleaning the boiler combustion chamber, it's really a good idea to get on site once a year, just because Mrs. Jones will tend to wait until that little drip that's been dripping for 6 months or 2 years or whatever it happens to be, it's going to be a real big drip before she really calls you in. So if you're in there to find it before it's a problem, you can fix a lot of stuff before it comes back to bite somebody. So
we suggest annually, minimally, clean the combustion. Don't check the combustion chamber, which you're going to do, on the first startup. But then annually, you should clean the trap, check for leaks, check for gas leaks, do a combustion analysis, compare this year's combustion analysis to last year's combustion analysis. And while you're doing your combustion analysis, you'll see what the stack temperature and the supply temperature is, and you'll know the need for taking the combustion chamber apart. That's an annual maintenance.
Where we can now read flame on the screen, well, we have been able to for a few years now, but the other thing I would recommend doing is when you install the boiler, do your combustion test. If you have those little printers, write the flame signal number on the high and low fire report. When you go back, and if you go back a year from now and your high and low fire numbers are set and your flame signal is in the exact same range, like let's say you had a new FTVN and it showed a flame signal on high fire of 115, just it's those ones. The computer engineers decided to convert the microamps into some random number, but typically on the new boilers, it's between 75 and 150 is a normal healthy signal. If you go back after a year and you've got the same flame signal that you had a year ago, your flame rod's in good working order. There's no need to touch it. If you go back and your flame signal has dropped, to half or a third of what it used to be, maybe now you're starting to run into a situation where your flame rod is aging and might need to be replaced, or maybe it's wearing out.
So David, here's a question for you, because I've come, before I get to the next slide, and I've often wondered this. So I've had a few over the years, igniters that have warped because of incorrectly set combustion. Some have closed, some have warped apart, some have warped sideways. Do you suggest during an annual maintenance to pull the igniter and inspect it?
Definitely inspect them. What I don't recommend is aggressively cleaning them. So if you've ever painted a car or really done much of any painting, the first thing they recommend you do is you clean and then you sand down the old surface to roughen it up so the new paint has something to stick to. If you sand down a flame rod with an aggressive cloth, like a emery cloth or whatever, you do the exact same thing to the flame rod, except what sticks to it is not paint, it's the corrosion that forms. And what we've generally found is you'll clean it, the flame signal will be fantastic for a short period of time, but then it tends to be that once you start cleaning it, you never get to stop, basically. A good healthy flame rod will develop a layer of corrosion, and eventually that layer gets thick enough that it begins to fracture on a microscopic scale. And as it fractures, it exposes fresh, clean metal underneath. And if you sand it down, the extra roughness that you've provided means that cracking won't occur, and your rods will tend to drop off in flame signal and have to be replaced more frequently than if you just left them be. So write down the flame signal when you install it, and then you have something to compare to. And for anybody taking notes, the TRX, FTVN, and Compass line, if you go into the menu and look at flame signal, 18 is the minimum acceptable signal that the boiler will allow to keep itself running. Below 18, but above 15, the boiler knows that there's a flame there, but it's just not good enough, and it will eventually fail. And below 15 is a fail.
And that has nothing. That has nothing to do with the actual the voltage put out. That's just a number that we've come up with.
Yeah, I think what happened is and I don't remember because it's been like 30 years since I did programming. There's a variable you can assign with a value between 0 and 255. It's a particular, anyway, so what they did was they scaled it between 0 and 255. So they take the microamps and whatever scale they chose, the typical signal you read on the screen is usually, it hovers close to 100, but we see them as high as 150 and as low as about 75 on new boilers, and 18 is where you start running into headaches.
That's a big difference. That's a big difference.
It is huge, and it is proportional to the flame signal, like the microamps.
It's a big range at the high end, 75 to 150.
Well, it depends whether you're on high or low fire and how your combustion is set and stuff like that. But on average, I would say it's about 100. So.
Okay.
So cool. So who does the maintenance? You do, of course. Be your hero and clean the boiler. This is one of my favorite things that David put in here was the flying Superman. Feel free to do it single-handedly. You increase your efficiency, you decrease your flue temperatures, so you protect your plastic venting. You reduce your callbacks, of course, and you increase the boiler performance, and your customers should thank you when you're all done, right? Increasing the boiler life and reduce their repair costs. Of course, your customer has no idea that this is happening, but they'll make them a happy customer to come back for another boiler. So with that, say thank you. I want to jump to a slide here real quick and just point something out one more time. Let me end this real fast. Did that end slideshow? There we go. So let me jump to another screen here for 1 second, right? So give me 1 second. Talk amongst yourselves.
Self, I say.
How was your vacation, Steve?
My vacation was wonderful.
Was it good?
Yeah.
Get all that chores done for Ann?
Everything's done, dude. Anyway, so let me go back to sharing my screen here.
Oh, there she is.
So I just wanted to go back to this, guys, and just show you that unlike any other manufacturer that I know of, you can have either your domestic right or your domestic left. You can have your heating right or left. You can have your heating straight through. And as Ted pointed out, that I didn't say because I don't give it much, never mind. But if you're going to an existing low loss header or an existing set of closely spaced T's, you can turn that valve off and you now have direct to that low loss header.